Okay, today year 10, it's the famous or infamous, I should say, completing the square process. Okay, so what we're going to do today is practice this particular skill and have a look at one particular application of it. So far with all the quadratic equations we have encountered, we have been able to factorize them and use the null factor law to find the solutions, which are the x-intercepts. What would happen if you came across a quadratic that you couldn't easily factorize? For example, this. So you'd get this one and you'd be like, ooh, yeah, cross method. All right, here we go. 5, 3, x, x, 5x, 3x is 8x. I could negate them both. -5, that's -8x. 15 and 1 is not going to work. Ooh, I can't factorize this. Okay, so what we need to be aware of is that if I did graph this function, which I'll do now, x squared plus 6x plus 15, let's have a look at it. There it is there. That's one reason why I can't factorize this function. Okay, so remember, you can only factorize a function that can be solved that actually has x-intercepts. And notice that this actually resides well above the x-axis. So that's why, or one reason why I can't factorize this one. But there are other reasons why I still can't factorize particular functions that do have x-intercepts. So you'll eventually have two extra methods to find solutions when you can't easily factorize using the cross method or a highest common factor. And we're going to look at complete the square. Right, so here's the following function. Y equals x squared plus 8x take 3. Let's try that one out and see what it looks like. There it is. Okay, so it's certainly got x-intercepts. So what you would do is, typically, and I always do, try the cross method, 3, 1, x, x, could be negative, in which case we've got negative 3x and x, reverse it up, and it's clear that we're never going to make that. Right, so what we do is we note that the form of the quadratic is in ax squared plus bx plus c. So what we'll do is complete the square to attempt to factorize the trinomial. Right, so what you need to envisage, and I think you guys as year 9s use the algebra tiles. I know Mr. Tench is a big fan of the algebra tiles here. And what you've got is the square, so that's x by x. And then this 8x here could be made by, remember those single x's that you had? So that could be those. How many of them is it? 8, 8, 8. All right, that's that part there. Now I know I've got to take 3, which would be 3 of those singles sitting somewhere. Now notice what that is, okay? This would almost form a square, okay? And to complete this square, because I imagine this is like, someone's just left it there and said to me, can you make this a square? Well, yeah, I can, okay? Because this is plus 4x here, this is plus 4x here. So what I would do is complete the square by doing a 4 and a 4, which means I would add 16 of those single units. Okay, that should be 4. I think I just added 5. Anyway, so that's the basic process. So what this represents is an incomplete square. And what I'm going to do is complete the square. Okay. So the process goes as follows. What you do is you only look at the first two terms of the trinomial. And what we want to do is make this a perfect square by completing the square. Now, over here visually, you saw that I added 16 or 4 squared. Now, how I can get what I need to add is simply halve this value here and square the value. Okay, so you'll notice on the next line, to complete the square, 4 must be added, 4 squared must be added, but also subtracted to maintain the same relationship. Okay, so notice that I've added 4 squared and taken 4 squared. Then you factorize the perfect square using the identity and simplify this to find the constant. Now, what I'm going to teach you girls is a bit of rote learning on this, but I'm just going to explain it this first time, x squared plus 8x plus 16. what we'll do is we always form a perfect square. Okay, so if and when you try to factorize that, you go 4, x, 8x, 8x. Yep, that's going to be x plus 4, x plus 4. So it's going to form that perfect square. I'm going to get you to try and shortcut this process that when you get this line here, you simply put the x there, this addition there, and the base in that spot there. And then to finish it off, we put negative 19 there because negative 16 take 3 is negative 19. So we have seen a technique to factorize this. Okay, so what we do know is that this could be written as y equals x plus 4 squared, take away root 19 all squared. Right, and then I can write this as x plus 4 plus root 19, x plus 4 take root 19. And if you know there, I've just used dots. All right, so hence solve it. Okay, well, let's get the solutions. Remember, the x-intercepts occur when y is equal to 0. X plus 4 plus root 19, x plus 4 take root 19. And that's going to be x equals take 4 take root 19, and x equals take 4 plus root 19, just using the null factor law there. So either that or that is equal to 0. And I've shortcutted that a bit there, and I probably should show you those steps. So that one there is obtained by me doing x plus 4 plus root 19 could be equal to 0. And then I've actually solved or made x the subject to lead me to that. And then I've done exactly the same thing with that. All right, let's just see what would have happened had I asked the calculator to do this for me. And the calculator gets the same answer. So here's the thing, girls. I'm afraid that the x-intercepts or the solutions to parabolas are not always nice, cushy numbers. Okay, so you can get these values here because a parabola, to be honest, is allowed to intercept the axes wherever it wants, including negative 8.3588989944 ... and this value here. Okay, so it can happen wherever you want. All right, so what we're going to do is factorize the right-hand side of the following equations. All right, so let's attempt to factorize on this. Here we go, cross method, yeah, all go. 6, 1, no, 3, 2, x, neg, so is it pos or neg? Either way, I'm not going to get to that. Ooh, what do I do now? All right, well, what I'm going to do is attempt to factorize via complete the square. So my recommendation is that you fence the first two terms off and imagine that like an incomplete square. What would you need to do? Well, here goes the process. Y equals x squared, take 8x, and remember what we do is we halve it and square it and add it because we want to complete an incomplete square. Now I write not plus 16, I actually write the base squared. So half it and square it, and I write 4 squared. And I'll explain in a sec why I do that. Now I'm going to subtract 16, so I do actually subtract the 4 squared plus 6. Now, in effect, I can ask you this question. In effect, what have I done to go from there to there? Well, nothing really. It's the exact same expression. So all I've done really is written the first term, the second term. I've added 16 and taken away 16. So why did I do it? Well, again, remember, I've just completed the square, which makes that a complete square or a perfect square. So that when I factorize it, and I could try that over here, I'll go x, and I've got to make 16 here, so that's 4 and 4, and both of them are negative. It's going to be x, that value there, this, okay, sorry, it's going to be not that sign there, which is take, and this base here, which is 4. So x take 4 all squared. All right, and now we're going to evaluate that, which is negative 16 plus 6 is negative 8. All right, so now we're going to factorize it. So I'm going to write that as root 8 squared, which then using dots is x take 4 take root 8, x take 4 plus root 8. Okay. give this one a go. So it's really evident the cross is not going to work on this one, so let's do it. Y equals x squared plus 4x. Okay, so you imagine that fenced off. I fenced mine off too early. Fence that off there. And then what we're going to do is halve it and add it with the square on it. We're going to subtract 2 squared, which is 4, plus 1. Y equals, all right, now that will form a perfect square, and you're more than welcome to try and factorize that trinomial. But trust me, it's that, and it's the base. All squared, take 3. All right, we're going to write that as a perfect square. Y equals x plus 2, take root 3. Y equals x plus 2 plus root 3. Okay, a couple more. This thing here, right, y equals x squared plus 2x. Fence that off, halve it, which is 1, and square it. That's 1 squared. Take 1 plus 5. Y equals, okay, so we've got the completed square there, which is x plus 1 all squared. That there, and the base there. Take 1 plus 5 is plus 4. All right, now let's factorize this using difference of perfect squares. And I say difference of perfect squares. Note that this is a plus. This doesn't factorize, okay? And I can't factorize this one even using complete the square. So what I suspect, girls, is that if I look at the graph, I bet you it doesn't have any x-intercepts. X squared plus 2x plus 5. Let's have a look. There it is there, no x-intercepts. So it doesn't factorize using the cross method, and certainly doesn't factorize when I throw complete the square at it. So doesn't have any x-intercepts, can't do anything else with that. All right, let's try this one here. Now these ones are hard. When I see the middle term as odd, it requires a little bit of fraction work. Okay, but that's all right, we're good at fractions. Okay, fence that off, x squared plus 3x. And what we're going to do is halve the 3x, or halve the 3, which is 3 on 2, and square it. So I'm going to add 3 on 2 all squared. Let's take that away, which is take away 9 on 4, because 3 on 2 all squared is 9 on 4. Take 5. All right, now we're going to go x plus 3 on 2 all squared. That, and the base. Now to do this part here, we've got 9 on 4, take, I'm going to put that over 4 and times that by 4. So it's going to be take 20 on 4. Okay, so now what I'm going to do is root that and square it. Y equals x plus 3 on 2 plus root 29 on 2. X plus 3 on 2, take root 29 on 2. Now y on 2, because I square rooted the 4 to make it a 2. Right, probably could just make one more move on this, x plus 3 plus root 29 all over 2, x plus 3 take root 29 all over 2. Okay, this one here, whenever we complete the square, here's our rule. So notice that all of the ones that we've seen before have all got a positive outside the x squared term, okay? So whenever we complete the square, we want this a value to be 1. Okay, now notice that this a value here is negative 1. Well, we can make an a value 1 quite easily by going negative x squared plus 5x take 2. All right, so now what we can do is complete the square on this thing here. So we're going to go y equals negative. Now, can you please help me out, girls, and follow my advice on this, which is open up some big square brackets. We're going to go x squared plus 5x, halve it and square it. So half of 5 is 5 on 2, and 5 on 2 squared is written as follows. Take 25 on 4, take away, let's write 2 as 8 on 4. Close the square brackets. y equals negative, square brackets, x plus 5 on 2 all squared, that, and that. Take 33 on 4 and finish your square brackets. Now, what we'll do is then factorize this thing by making that square root and squared. So we're going to say that y equals negative square brackets x plus 5 on 2 take root 33 on 2 x plus 5 on 2 plus root 33 on 2 because I've square rooted the 4 there. Okay, and close that, and let's just tidy up one more thing. So we're going to say negative All right, so we don't need those square brackets because in fact this is -1 multiplied by this, and it doesn't matter that I do this multiplication first and this next. Okay, so we can just get rid of those square brackets and stick the negative sign out like that. All right, and I think this will probably be the last one. Okay, all right, so this is really tricky. All right, so remember I said that when we complete the square, we want ax squared plus bx plus c. We want that form there, and we want this a value to be 1. So this is a problem here. So what I'm going to do is take 3 out as a common factor. Now, I can hear you sort of yelling at the YouTube clip now, but 3 is not a common factor. Well, not really. I mean, I can sort of still get around that. So check this move out. All right, so what have I done there? Okay, so basically what I've done is taken out 3 as a common factor, even though it strictly speaking isn't a factor of all 3 terms. Now 3 times x squared is 3x squared. 3 times 4x on 3 is 12x on 3. 12x on 3 is simply 4x. 3 times -1 is -3. All right, so that's what I'm allowed to do. All right, now what I'm going to do is complete the square. So I've got 3. And what am I going to do? I'm going to go x squared plus 4x on 3. All right, now what I've got to do is half that and square it. So 4 on 3 halved is 4 on 3 times 1 on 2, 4 on 6. Okay, so I'm going to add 4 on 6 all squared. Need these square brackets here. Now I'm going to take it away. 4 squared is 16 on 36. Take away, instead of writing 1, I'm going to do 36 on 36. Close these square brackets. Okay, keep those square brackets in. X plus, now that's 4 on 6. I'm just going to write that as 2 on 3. All squared. Take, there's going to be a simplify here. I've missed a, I should have simplified it there. It doesn't really matter, but now -36, -46, -52 on 36. Close that. Y equals 3. What's that? 26 on 18. Yep, that'll do. Y equals 3. What I'm going to do is 26 on 18, square root it and square it. Close that off. Y equals 3. X plus 2 on 3 take root 26 on root 18. And x plus 2 on 3 plus root 26 on root 18. Now, let's get rid of these square brackets. Let's also try to simplify any surds. So root 26 is, what's that, 2 times 13? No, that can't move. root 18 is going to be root 9 times root 2, which is 3 root 2. So I'm going to write that as x plus 2 on 3 take root 26 over 3 root 2. I have to write small here. I'm just going to squeeze that in here. So multiply by, and I'm just going to pop it down here. X plus 2 on 3 plus root 26 over 3 root 2. All right. So it's not easy to complete the square, particularly on problems like this. That's as hard as it gets. Okay, but routinely you will be using complete the square on things like this in year 11 and year 12. So good practice to do as many of these problems as you can get your hands on.